Hello everyone, this is Doug, and in this lesson we're going to keep on talking about functional groups and identifying amines, alcohols, and alkenes. If you recall from part one of this of these two videos, there are many different functional groups. We are not covering all of them. There are dozens and dozens and dozens. I want you to know these six. I want you to know the hydroxyl group. I want you to know the amino group, the alkenes, and then only three in the carbonyl family. So aldehydes, ketones, and carbonyls. And remember that we talked about aldehydes. We differentiated between aldehydes and ketones and carboxyls in part one. So in that other video, hopefully you already saw that one. So this one, we're going to talk about the hydroxyl group, also known as the alcohols, the amino group, which is a type of amine, and then the alkenes, which are all just known as alkenes. They don't have any other special name. So let's take a look at our first. If I look at my amines, right, what we're looking for the amino group is some sort of R group. Doesn't really matter what's attached to it, but we're looking for an N with two hydrogens attached to it. And we're going to call that our amino group. So that's the amino group. If some molecule has an amino group on it, then we call it an amine. So if you hear about some sort of amine, that means that it has an amino. It may have an amino group on it. If it has an amino group, it is an amine. There are multiple types of amines. We are not going to talk about primary, secondary, tertiary amines for this class, so you don't need to worry about that stuff. I just want you to know what an amino group is. So if I look at some molecule like this is just ethylamine, but I see that there's an amino group on it. And here is alanine, which is an amino acid, and it has an amino group on it also. And again, like I mentioned in the last video, one of the reasons we learn these functional groups, aside from being able to predict chemical and physical properties, is that a lot of categories of molecules are defined by the functional groups. So like amino acids, like this amino acid, this is alanine, like I just said, this is alanine, the amino acid. Alanine has an amino group in it, which is why it's an amino acid. If I go down and look at these four molecules and I start scanning for amines, right, again, I'm looking for NH2. So I'm looking for nitrogen with two hydrogen on it. If I look down here at dopamine, right, it's got the word amine in it, so you can guess it's probably going to have some sort of nitrogen group. And sure enough, over here on the right-hand side, I have an amino group, right? I have my N with two nitrogens attached to it. You don't have to draw it out with the lines. It can just be NH2 in sort of a condensed structural formula. That's totally fine. Vanillin over here, I don't see any nitrogens at all, so no amino groups. Same thing for this steroid, I don't see any amino groups. And then if I look over here at this lysine, valine lysine dipeptide, I'm looking for nitrogens with two hydrogens attached, and I see one over here on the left. This is H2N, but that means the same thing, it's just on the left, not the right. So this is an amino. I definitely see students freak out sometimes when it's NH2 instead of H2N instead of NH2. This one's just written like this because it's showing that the nitrogen's on the left-hand side, and so the order of attachment is that you have hydrogens on a nitrogen, which is then attached to that carbon that's in that V shape. So NH2 is same thing as H2N. It doesn't matter which way you see it. I see another NH2 over here, so there's a second amine hanging off of this. And I do see a nitrogen right here, but this is not an amino group because it's not an NH2 and because it's attached to a carbonyl, so that's not an amino group, so I'm not going to circle that one. I'm just going to leave it as it is. So it looks like in these four molecules, only two of them have amino groups, the dopamine and then this dipeptide on the right-hand side. So that's what we're looking for the amino group. And that makes both of those molecules, the one on the left, the dopamine, and the one on the right, the dipeptide, amines. They have amines in them. Now, if I take a look at the alcohols, right, everyone's heard the word alcohol before. Alcohols are just some R group with an O and then an H attached. So I'm just looking for an oxygen and a hydrogen attached, and this is a hydroxyl group. Not to be confused with hydroxide. I often have students mix the two, right? Hydroxide, remember that since it ends in "ide", that's talking about the O minus. That's talking about the polyatomic ion. That is not this. Hydroxide is just a free ion like sodium hydroxide, potassium hydroxide, calcium hydroxide. Hydroxyl, which ends in YL, that's attached to something organic, right? Remember that this R group is some organic piece. Some sort of organic piece. And that's all we're looking for, right? So if a molecule has a hydroxyl group on it, that makes it an alcohol. Alcohols have hydroxyl groups. And so you might hear things like, this is isopropyl alcohol or isopropanol. Isopropyl alcohol, also known as rubbing alcohol, right? It's got an OH group on it, which is why it's an alcohol. If you think of like the drinking ethanol, drinking alcohol, ethanol. Here's ethanol, right? So that stuff in like wine and beer and stuff like that. All of your alcohols, the sugar alcohols like xylitol or erythritol, those all just have a whole bunch of OH groups on them. And that's all we're looking for. A carbon that has an O and an H attached to it, but is not a carboxyl. And I'll show you what I mean more in a second. If I look at dopamine, sure enough, here I have a carbon with an OH on it and a carbon with an OH on it. Both of these would be considered hydroxyl groups. So I have 2 hydroxyl groups. I have 2 alcohols on dopamine. And again, just like with the amine, don't freak out if it says HO instead of OH. What's important is that you have a hydrogen on an oxygen, and that oxygen is on the carbon. That's what we're really looking for here. If I go to vanillin, I see a bunch of oxygens. Here's a C double bond O, that's a carbonyl. This has oxygen with a carbon attached to it and a carbon attached to it. Remember that this end is a carbon, that's actually a CH3 there. But I do, if I look down here at the bottom, it looks like I do actually have an OH here, so I have a hydroxyl. I have a hydroxyl down there. So vanillin has a hydroxyl also. If I look at the steroid over here, I've got one hydroxyl up there. And if I look over here at my valine lysine dipeptide, I don't see any hydroxyls, right? You might be tempted, people are often tempted to be like, ooh, look, there's an OH. But remember that that is not a hydroxyl. That is a carboxyl from part 1. Let me write that out a little bit neater. Right, that's a carboxyl from the first video, right? Because that OH is attached to a carbonyl. So that's actually a carboxyl, not a hydroxyl. So just be mindful, pay attention to the fact that if that OH is attached to a carbon that's in a carbonyl, totally different functional group, different chemical properties, different behavior, different acidity, everything. So they're very, very different. So it's not a hydroxyl, it's a carboxyl. And so that's how we find those alcohol groups, those hydroxyl groups. Looking for a carbon with an O and an H. If lastly here I look at alkenes, right? Alkenes are simply carbon-carbon double bonds. That's all we're looking for here. Doesn't really matter what's attached to them. Can be kind of whatever, hydrogens or carbon groups, but we're looking for a CC double bond. That's your alkene. And alkenes are all over natural products. I have here an isoprene, so this has 2 alkenes in it. That's the building block of all the terpenes and steroids. This is limonene, which you might recognize as like a smell of lemon, citrus stuff. But again, here's a couple of alkenes. And then if I take a look at my molecules down here, now I'm just looking for carbons that are double bonded to one another, right? So here's carbons that are single bonded to each other. That's not an alkene. But if I look in this ring, it looks like I actually have 1, 2, 3 alkenes in here. And if you're thinking to yourself, ooh, I read something about aromatic compounds or arenes. Yes, that's technically an aromatic compound. It's an arene. I don't really care that you know that for my intro-level classes. I just want you to see that those are alkenes. They have CC double bonds. Same thing for vanillin. Vanillin's got a whole bunch of alkenes in them because I have a whole bunch of those CC double bonds. And if I go over here to that steroid, it looks like this steroid also has an alkene in it, right? There's a CC double bond. I see a CO double bond. That's not an alkene, right? It's just the CC, just carbon-carbon. So I have an alkene over here. And then if I look over on this, that's actually a triple bond. So I've got the 3 lines. That's not an alkene. That's an alkyne. I don't care that you know about alkynes. They're not very common in natural products. So we're not going to see very many alkynes at all. We probably won't see any alkynes. Not very common. And then lastly, in that dipeptide, I don't see any carbon-carbon double bonds at all. I see carbon-oxygen double bonds, and that's it. And I see carbon-carbon single bonds, but no alkenes. So our alkenes, right, are simply just carbon-carbon double bonds. That's it. That's all I'm looking for the alkenes. And later in the class, we'll talk about the reactions to alkenes, how we make them, their interactions with coenzymes like FDA or FAD, stuff like that. So now what you want to be able to do, right, is you want to be able to look at a series of molecules and find the functional groups that we talked about, those 6 that we talked about. So here are 5. I recommend that you pause for a second, write them down, try to identify all the ones that you can. I've posted worksheets on our website, so you can take a look at that. So go ahead and pause for a sec, see what you can do with this, and then I will go through all the different functional groups with you in just one moment. So if I take a look at this one, right, let's start with the pyruvic acid here. I'm going to start with this one right here. It looks like I'm just going to start with all my ketones. Try to find all of my ketones. I know that that's a ketone, right? Because again, it's attached to 2 carbons. And that's not a ketone up here on glucose because that's a acetyl-1O with it's a different functional group. No ketones over on this dipeptide, no ketones on vanillin, but I do have a ketone here on that steroid. There's my ketone, right? Because again, it's attached to 2 carbons. I can also look at my carboxylic acids, so I'll do my carboxyl. Because, right, remember from that previous video, the carboxyls were when you had a carbonyl with an OH attached, so there's my carboxyl. Glucose doesn't have any carboxyls. Looks like I do have a carboxyl in my dipeptide over here. So carboxyl over there. And no other ones. No carboxyl in vanillin, no carboxyl in that steroid. Then lastly, the aldehyde, right? So I do have an aldehyde here. So there's my aldehyde at the top of glucose. No aldehyde in my dipeptide. I do have an aldehyde in my vanillin. Because again, right, remember the aldehydes are carbonyls with H's attached, so it's really this H that makes it an aldehyde. It's directly attached. And then I don't have any carbonyls at all for that dipeptide, or sorry, for that steroid there at the bottom. Now if I go back and I start looking for something like alcohols, right, so my hydroxyl groups, I am not going to recircle the one in pyruvic acid, that OH in pyruvic acid, because it's part of a carboxyl, so that's a separate functional group. Alcohols are when they're just attached to normal carbons. So like in glucose, I have 1, 2, 3, 4, 5. It looks like I have 5 hydroxyl groups, 5 alcohols. 5 hydroxyl groups there. And if I go to the threonine alanine dipeptide, look, here's another hydroxyl right up there. Got one in there. Vanillin looks like we have a hydroxyl down here. I'm not circling this oxygen over there on the right because it's attached to a carbon, not an H. And then I have one more hydroxyl up here. I have another hydroxyl up there. So that's all my hydroxyls that I can find. We also mentioned amines. So my threonine alanine, here's an amine. An amino group. Put an amino group. That one in the middle here next to the carbonyl is not an amino because it's attached to a carbonyl and because it does not have 2 H's. No nitrogens at all in vanillin, no nitrogens at all in this steroid. So I think that's all the amino groups. And then lastly, alkenes. So do I have alkenes in things? So let's see if I can find some alkenes. No alkenes in any of the top 3. The only double bonds I have are CO double bonds, so none in there. But I do see some right here in my vanillin. So I do have some alkenes there. And I have 1 alkene in my hormone. And so that's what I would expect from you if I asked you to circle and label all the functional groups in these molecules. Again, it's just those 6. If you see something that looks interesting, like an alkyne, like this amide, but they're not functional groups that we talked about, they're not the 6 that I put on that second slide, don't worry about them. Don't circle them. Don't try to make them something that they're not. So that's kind of your introduction to identifying some functional groups. Again, for my classes, these are just the 6, but there are dozens and dozens and dozens out in the real world. If you came upon here and you're taking organic chemistry, you're going to want to look up all of those other ones that are out there. But if you have any questions or comments, please leave them below, and happy studying.